Hello everybody, welcome to this session about Azure Arc and Managed Identity. My first session on a stage, so really thankful about this opportunity. So before we start, I just want to quickly introduce myself. My name is Pratheep Sinnathurai. I am from Switzerland, working for Base Vision, and since probably 1 year, I'm working as an Azure engineer. So as the topic from today is Azure Arc, I want to tell you something about Azure Arc. So there are already people in here which are using Azure Arc in a production environment. So few hands, so quite cool. So before I was an Azure engineer, I was working as workplace engineer, where I had a lot of projects where we had tools like Config Manager to manage clients. And as workplace engineer, I had the project to switch from Config Manager to Intune. And during this project, I asked my customer, hey, now we got a solution for your clients, right? But what should we do with all your servers? So Microsoft's answer to this question was Azure Arc. So what Azure Arc is basically doing is extends the capabilities of Azure Arc Manager for Azure to your on-prem or multi-cloud server. So if I install the agent on a Windows server and connect my Windows server to Azure, what it will do, it will create a managed identity and an Azure Arc resource. So the Azure Arc Managed Identity, what's the topic about from today, is here for the authorization and authentication part of your Windows server. And using this managed identity, your Windows server can then talk with Azure to maybe send heartbeat data and all of those other stuff. And topic about today is how we can use this managed identity to do things. So the issue, so let's assume you have a storage account, right? And you want to upload a file. So before Azure Arc, you would use a SaaS token. And a SaaS token has a lot of problems about the security perspective, right? Because we need to save the SaaS token somewhere in a script. The SaaS token could be compromised. And at the end, Azure AD authentication and OAuth is just more secure than using a SaaS token. So let's do a quick demo. So we are here in the Azure portal.
You have this for you.
Oh, thanks a lot, thanks a lot. So here we are in the Azure portal, and we can go to the Azure Arc part, and here to our servers. So from this perspective, we see, hey, I've got a lot of servers in here. They are connected, and with which resource group and all that stuff.
Increase the font.
Sorry?
Increase the font.
Is it?
Yeah.
Yeah, okay, perfect. All right. And if we now go into the Azure AD part, go into the enterprise application, searching for managed identities, we'll also see here, we have here all those servers, all those Azure Arc resources also included here. As an example, that one. So let's go now to in Azure to the Windows server. Quick fun fact about this topic. I prepared before a VPN connection to my lab at home, but the VPN connection was not working in the morning. And yesterday it was working, so that's what I tell my customer always. Hey, it worked yesterday. But I found a way with Windows Admin Center to connect it from here. I hope it works. So let's see if that works. Hey, cool. from here on, just quickly, Windows Admin Center extension, one cool thing, as soon as this is out of preview, I will definitely use that in a production environment. Because with this, I can just install the extension and use connect to my on-prem server without any VPN network configuration. So as we see here, that server is at Switzerland under my table, and here we are on my server. So let me quickly, yeah, cool. So what I wanted to show you, so first thing I already did that, installed the Azure CM Agent exe. Let's prove that. So we see the Azure CM Agent exe is installed. The resource is here. Status is connected. And everything working fine. Perfect. So as soon as the CM Agent exe is installed, it will create an environment variable. Identity endpoint, scroll it down. So from an Azure Arc perspective, it's that specific URL, and with using that specific URL, it can get a token, and using that token, we can authenticate against Azure Arc. So I don't need to save any kind of credential in here. It will automatically get the token, and we can authenticate against Azure. So to prove that, let me connect to Azure account. Let me. So what I will. Oh, sorry. I just say connect to using the CMDLET, using the identity parameter, and saying, hey, use it the variable which we saw before, and we can just automatically authenticate against Azure. So we see that's my subscription, my tenant ID, working perfectly fine. So that's the Windows Server part. So if we want to now upload the file to storage account, just quickly show you how that looked like. So we go into here to the containers. I've already prepared the container. Under the access control part, I go to role assignment. And we see here, somewhere, here, storage blob data contributor. So that means that's the role to upload or modify of blob data for my managed identity. And from now, if we go back to the server, I can use also AC copy. AC copy. I already prepared the command. So I just can, not that one. Also using the AC copy to log in with the identity parameter. Okay, that's not working. Wrong folder. And we see login with identity succeeded. I've already prepared a file, which will be uploaded to my storage account, running at that account, and all right, looking fine. And if we are going back to the storage account, we'll see here that the file is now uploaded. Okay, half minute left. Perfect. Thank you very much. So that was it from my side. I hope there aren't any questions, or are there? It's just basically working right. I think a really good, cool tool, and I hope that with Azure Arc there will be a lot of mock-up opportunities for that. Question? I've never used it before, to be honest, so I don't know if is it possible. Okay, he said it is possible. Oh, sorry. The question was, can we also use the managed identity authenticate on a Linux server, right? So the answer is yes. Another question? So the question was if you can start the authentication from the other side, from Azure downwards to your on-prem server. Can you? Use an Azure runbook. To be honest, I have never tested it out. Okay, yeah, all right. Okay, good. All right, thank you. All right. Then from my side, thank you. Thanks all the sponsors. And
It is. Everything's being done in code spaces. Hey, everyone. I'm doing a demo. I have no slides. It's a quick thing. So my first session that I did was on managed identities. And there was one thing that I talked so long that I didn't have time to talk about this one cool thing. So this one weird trick that doctors hate with managed identities is, in theory, you're supposed to create them and never actually do anything other than Azure-y things with them. But you can kind of use them also kind of like service principals and force in graph permissions to do graph calls in your services, things like Azure Functions and Azure Runbooks. So this is kind of perfect that we were just talking about managed identities before, and we're still talking about managed identities. So I just have a really basic script that will let us, when we have a managed identity, force in graph permissions into it so that we can do things. It's probably not even going to be 10 minutes, so let's just have a quick look. So I have an Azure function here called quick demo, because I literally just wrote it, that is going to connect in to graph, and I don't even know what I'm doing, listing just a bunch of devices. Why would you do this? It doesn't really matter. The important thing about the function is this top section, and I talked about a bit about this in the API demo that I did yesterday as well. I just have, in general, a thing that checks to see whether I have a managed identity in my instance in the environment variables when I'm running in Azure. If I do, I use that to get my access to graph. So all I'm doing here is just saying, yep, cool, if I have MSI secret in my environment variables, then I'm going to get an access token for graph.microsoft.com, grab that token, and then I'm just going to use that. If I'm developing locally, I bypass that and I just use a service principal. It's nice and simple. Everything else in the actual function app itself is kind of boring and unnecessary. It's all on GitHub. We can talk about it after. The real reason you're here is to see how we put those permissions in, and we can explain why that's important. So I'm going to go over to Azure. I'm in my function app called PSConfEU 2023 Quick Demo. We're going to go into Identity, and we're going to just turn this on and save. Depending on how Azure's feeling, this can take anywhere up to 5 minutes to actually work. Depending on what side or direction of the world you're on, it can take longer. Australia kind of sucks. Okay, so we have an object principal ID. That's awesome. That means we've got a managed identity. If we pop over to AAD and we just refresh this, I'm in enterprise applications and I've just changed the application type to managed identities. We'll see here that I've got an enterprise application or a managed identity of the same name as my application that I've created. This is by design. This is the same. This will happen for anything. So the managed identity has the same name as the thing that you created it for if you're doing system-based. If we go in here, this kind of looks exactly the same as a service principal, but there's limitations in the UI. That's by design. You're not really meant to interact with it yourself. If we go into permissions, where you would normally go in to put the API permissions, you'll note that everything is grayed out. There is no option to add. There's no option to remove or grant. It's got grant admin consent, but you physically cannot use it. So this is the initial sort of stumbling block that everyone gets. Well, I want to use managed identity because people like me say, hey, You have to use them because otherwise you're going to be putting your secrets out in the world, but I can't do the thing I need to do. So very small script. Let's go back over to my code spaces. Let's go into this file called April owes me a beer. And we'll see if code spaces is going to fail on me. Oh my God. Let's do this. It's going to set up my code spaces. Come on. This is working really well so far. Okay. I have a function here called add graph API role to MSI. Let's open this up and have a quick look at what it is. It's nothing super exciting. We've got an application name, we've got a graph API rule and a token. We're going into the service principles of graph, and we're essentially just looking for that managed identity that we've created. I'm just doing a name search. You can do ID search or the object ID. It doesn't matter. This can be improved. This is not a production thing. This is just a thing that we can sort of play around with. Once we've got the name and we've got the permission, we basically just go through a list of the API permissions that you need and just inject them into the managed identity. If we have a look at, we'll go into the for each. Am I going for time? Heaps of time. I'm basically just iterating through a list of graph roles and just adding them in. I've got principal ID, resource ID, and app role ID. Again, this is on GitHub, so you can spend more time and you can ask me more questions about it after this. But essentially, what I'm going to do down here is I'm going to connect into my Azure tenant. I'm going to get the access token for graph. I've got my roles here that I want to add to my tenant so that my function app can work. So read, write, all for device management apps, device management configuration, things like that. And then I'm just going to yeet them into my managed identity. Seems pretty simple. Let's see if it actually works. Okay. Let's shrink this down. Just going to load this into memory. F8. Seems good. Let's auth. Doing device authentication because Codespaces doesn't let you tunnel back out to the browser. Need a bad time to ask for my password. Yes. Okay, we have authenticated. Let's go back to Codespaces. Okay, I'm just going to swap that identity out and grab a token. And then I'm going to get the roles and add to the Graph API. Let's do this really quickly. F8. The term VI. Oh, that's cool. Control Z. Yeah. I mean, it actually kind of worked, which is funny, but let's just do this again. So quiet. Okay, so this is actually kind of a cool demo because you note there that I've got one green thing and then, well, technically that's yellow, but it's saying that I've already found those permissions because we sort of jankily ran it the first time. So you can just keep running this and running this and running this, and it's going to verify that the permissions are there. So we know the demo was successful. If I go into my permissions here and just refresh this, we've now got graph stuff in our managed identity. Okay, now, I have 2 minutes. This isn't going to work because realistically, when you add these permissions, it can take up to 15 minutes to actually reflect. I don't have 15 minutes. So let's go in and just try and run it and just see what happens. It's probably going to 401, but if it works, it'll be really cool. We'll go code and test. In where's my thunderclone? Why is everything so slow? Okay. Quick demo. While we're waiting for this to load, because it's probably not going to work, does anyone have any questions on what I just showed you? So the question is, why is it not in the portal? I think the short answer is because you're not really supposed to do this. The the managed identity is really meant for you to just like work with resources in Azure. It's not meant for you to use Graph and do things, but it is just a service principal. The difference between a service principal and managed identity is Microsoft manages the credential for you. That's really the only difference. So what I'm saying could be wrong. It could just be that the UI is slow and it could be updated and we could do this. But it's, I think primarily because you never know what the credentials are and you're not in control of it, they try to lock down, sort of the blast radius of potential implications with this, is the short answer. Okay, let me see if I can quickly run this. Test and run. It's not going to work. And we're going to hit run. Okay, it's doing a thing. It's going to build on cold start, so it's going to take a little while. And we're going to get a 401, I'm certain of it. Because I'm confident in my failure. Does anyone have any other questions? Hang on, can you repeat the question? So the question was, can we use this in combination with application registrations and enterprise apps? Yes, but in theory, you would never need to programmatically add those permissions to those things. You can't change an application that you don't own. So if you have enrolled someone else's enterprise application into your tenant, you can't change the permissions there. But with an app registration, yes, you can absolutely do that. Question in the back?
This applies to permissions, but it also applies to app roles within Azure.
Okay, the question was, so the demo applied to permissions, does it apply to roles? You can change roles like yourself. So yes, you can absolutely do this. This function doesn't do that because you can do that. That's what managed identities are for. You create the managed identity on the resource, and then you say, well, what roles do I want this managed identity to have? Good question. Okay, yes, it failed exactly as I thought. If I let this go for like 30 minutes, it would probably be okay. But cool. I have 40 seconds. One more question. I'll tell you later. Okay, thank you. I'm done.
So my name is Justin Grote. I'm a data center solutions architect and Microsoft MVP. Today I'm just going to be showing you my PowerShell prompt. So I've been kind of tuning and tweaking and working with PowerShell prompt customization for quite a while now. Tried all the different variants, everything from doing it from scratch myself using ANSI codes to using some things that sort of came along. And I'm going to show you just a couple of those options that have been. In the past, there's just editing your profile, which has always been quite a endeavor, especially in the old PowerShell days where it was really hard to do ANSI codes and compatibility and all that kind of stuff. Then this thing came along, Starship. This was basically a way to write prompts, and it was all written in Rust, originally in Go, but now it's in Rust. And it was a way to have a cross-platform way where it would handle all the color coding and making your prompt nice and all that kind of stuff. It's still a really great option. And before that, Jan de Dobler, who does the original Oh My Posh, decided, hey, this is a really cool model because, like, why should I just only be stuck in PowerShell? And also the way that it gets run in PowerShell, just prompts have to be really, really fast, and there's just some limitations about doing it purely in PowerShell. So he decided to do it and decided to rewrite it in Go and create this new prompt theme engine called Oh My Posh. The name comes from, there's the Z shell and ZSH, and the most popular customization for that is called Oh My ZSH, and so this is sort of like a variant on that. But so this is actually a really great product. It's come together really well. It's very well documented. It's gone through a few revisions, some breaking changes, but it's really basically a really nice way to manage your prompt. It's the way that I manage my prompt today. So, as a quick demo of my prompt, as you can see, my prompt doesn't have a lot of words or anything. I really like my prompts to be minimal. I like them to just only show me the context that I care about. So a real simple thing is, like, if I go into my projects folder, notice how that icon changes to a construction icon. Again, I don't want to see projects. It's just more noise that I don't want to see. So I just have like a little easy visual indicator. It's like, oh, I'm in my projects folder. And if I go to one of my projects, like say Posh Anywhere, which I'll be demoing in a couple hours, you get a little bit more. This kind of doesn't look quite right when it's that big, but let's clear that. So what you get here is just a little bit more contextual information. So since I'm in a Git repository, it tells me what branch I'm on. And since this is a .NET project, it tells me what my .NET SDK version is. And so I didn't write any of these pieces. These pieces just come built into Oh My Posh. You just have to structure them where you want them. And then there's a couple of tricky things that I added that I used to do in my own prompt customization days that I really liked. Like for instance, if I'm debugging something, I like to know that I'm in the debugger. So if I wait debugger, my prompt changes so that I get that nice little ladybug bug there with a little prompt. And so that lets me know, okay, I'm in the debugger. And like, not as big of a deal when you're on the command line, but all this works in Visual Studio Code as well. So it's a really handy reminder, like, oh yeah, that's right, I'm debugging something if like something doesn't look right. And then when I drop back out, it's fine. Another thing is that if I run a command that throws a terminating error, when the prompt comes back, it's gonna let me know, hey, that last command failed, which is really good for things that maybe take a while. And you've probably seen in the upper right, there's a little timer. Every command that I run, it lets me know how long that command took to run. So whereas tools like Profiler and such are really good for trying to get the nitty gritty, sometimes you just kind of want to get an idea of what a command does, and I just have that feedback there right away. And if I go back to my main here, get rid of some of that noise, you know, I can do something like HTTP stat US/200. And you can see, okay, that took about 400 milliseconds to run. So it's just a really handy thing. So how this works is they have all the instructions here. But basically there is, if you go to this site, which is my justingrote.files, this is all my config of my personal stuff. And this is all set up using a tool called Chamois. I'm not going to talk too much about Chamois, but basically this is sort of like VS Code sync. If you use like the sync settings, it's like that, but for all your like your local files. So when I go to a new computer, I literally just run this command with my username, my GitHub username, Justin Grote. And it goes out, it checks out the repository, and then it follows all the templating and lays out all my dot files how I want them. All my config files, my PowerShell profile. So and this is in a Docker container, a Linux server, Windows server, wherever, lays it all out. So really handy way to get that. So inside my files, you'll find here under this sort of special folder, my profile, but also you'll see here there's an Oh My Posh, and there's this omp.yaml. So the nice thing about this too is it leverages the Go templating engine, so it supports JSON, YAML, TOML, take your favorite. I like YAML a lot. Feel free to flame me about it, but I think YAML is great. And so here is my profile version. So as you can see, this probably looks a little complicated. I'm just going to scroll through it here real quick. Let's bring that up big. Just going to show that there's all kinds of different levels here. One key thing is that it does have a schema. So if you put this at the top, as you go to write and edit things, you will get IntelliSense for what your options are, including descriptions and links to the description of what that particular configuration setting is. Really nice, makes it really easy if you haven't really worked with this format before. So in the prompts, you can make them fairly simple. I have some sort of tuning and tweaking here to make it work kind of the way that I like. One other thing too is that it uses a thing called nerd fonts, which if you go to the repository, if you go to Oh My Posh, it'll tell you all about them. But basically, there are these patched versions of fonts that you can get that include all kinds of additional symbols that make it really easy, in addition to emojis, that make it really easy to make your prompts look really nice. And so those are pretty easy to go out and get. So as far as these go, you start with a blocks level at the top, and then you have various prompts. So you have different prompts. I start with my first prompt, which is the left-aligned side. I like to have this diamond here. I got to do a little bit of a workaround here for SSH. Basically, this is if I'm locally on my computer, I know I'm locally on my computer. Don't say what it is. But if I'm remoted on another computer, show me my username and my account that I'm logged into the other computer. Again, it's a real simple reminder in my prompt that's contextual to remind me, hey, this is a remote computer, so don't delete. If this is a server, don't go thinking it's your local prompt deleting local files. Just a handy reminder. This next section provides some information for those mappings. So rather than just see the tilde like you do in the basic prompt, it maps it to the home. My projects, it maps it to this nice little construction icon. Documents, I get a nice little document icon. My config folder, I get a little gear. And then anything beyond that, it'll add the slashes. And then there's a little thing here this is the part of the Git part that you saw that basically runs a little thing. This is all the Git templating engine, the Go templating engine, where you basically define some stuff and do some fancy stuff where it's like, hey, You'll see a lot of times where it's like if the terminal program isn't VS Code, because when I'm in VS Code, I have all this stuff in Git Graph and all other kind of extensions. I don't need to see it in my terminal. That's just, again, those are just my preferences. Some people have terminals, they want to see everything in their prompt, and that's fine. But my style is like, if I can get the information elsewhere or it's not relevant to what I'm working on right now, it's just mental noise to me, so I don't want to see it. But this is what basically does the fancy stuff of checking that if there's am I in a certain branch, are there changes, and show me things in my prompt to see that. Now here's where we get into some of like the built-in ones. So for instance, that .NET to tell what the my version of .NET was, this is just simply, this is all you got to have. Type .NET style diamond. This is like a pre-configured thing that will simply do it in that way. And the style diamond just has to do with the way you want to arrange your prompt. Whether you want to do like the pipeline style or like individual sections, or whether you want to have all kinds of, it's all just in terms of the styling stuff. Here's where the execution time comes in. This is one thing that's sort of a little special. You can see the templating. There's that formatted MS. That's where it basically pulls out the variable for what the execution time was of the last command. And then these numbers are just sort of setting the various transparencies and stuff to make it all look nice and pretty. Then you finally have the left alignment. That's everything that's on the right side. Then when you get to my actual main left prompt, you have things like, am I in root? So like if I'm logged in as root, or if I have admin credentials in Windows, show me a little lightning bolt next to my thing so I know like, hey, you're in danger mode right now. Here's that part for exit. And as you can see, it's real simple. I didn't have to write a lot of code for that. It's built into Posh. So I just had to decide, hey, what symbol do I want to show for that exit? Sometimes if I'm not in my default shell, I want to see that I'm in ZSH, because this doesn't just work for PowerShell. If when I'm in my other servers and I log in, I'm in Bash or ZSH, Posh works for all of those too. So I get the same consistent prompt through all of them, minus some obvious minor compatibility issues. Valid line, error line, secondary prompt. This is the one where I don't think I showed that. I'll do it real quick. Where as I'm typing, if my command line isn't complete, like if my command line is not a valid command, you'll see that the arrow changes, and it's like, okay, now it's a valid command, so it goes green. And if I'm in the process, I haven't finished a command, the prompt changes to blue arrow. This is all just the same stuff as you see when you get like the double arrow, you know, when you get a line continuation. It's just prettier and nicer, and I like it that way. And so this is basically just an easy way to customize. To get started, just go to Posh. Start with the introduction. There are a ton of built-in themes that exist already, so you can see all these different ways. You can pick one that you like. You're like, oh, this is a good start. And then you'll get that config file, and then you can just tune and tweak it to your liking. So that's my presentation. Thank you very much. I got about a minute for any quick, oh, sorry, thank you. I got about a minute for any quick questions. Yeah. So the question is, are there any performance applications for calling out to an external application versus using straight PowerShell? So the nice thing about these is because they're written in things like Rust and Go, they're designed to be very, very light and have their dependencies light. So a lot of what they have to do and not initialize actually tends to be faster than what you would be able to accomplish in PowerShell, because PowerShell relies on .NET. And even though it ships with a lot of stuff, that stuff's not preloaded. And at the time it takes to go fetch that assembly, and you get, if you've heard the banana monkey jungle thing where it's like, I'm loading this whole assembly just for this one little thing, that kind of stuff happens in that. Whereas these other ways of doing it are able to just keep everything lean to just what you need for the prompt. So these actually tend to be much faster. In fact, you probably saw with my prompt, my base prompt, comes back almost immediately. Whereas my older prompts tended to have like a little bit more delay. Now that entirely depends on what you put in your prompt. It's not always going to be fast, but this is sort of what's been determined to be sort of the fastest way to do those things. Any other questions? All right, thank you very much.
Now we had some exciting topics about playing around with your prompt, awesome, or credentials, Azure. And I thought, how about I go back to some PowerShell basics, something that applies to every single console out there. There is one feature in PowerShell that we all really, really like using, whether we admit that or not. It's called the pipeline. But what happens when this vertical bar starts up and our commands start running, and what does this mean for our code? So we're going to visualize how the pipeline executes. First, we need a few items that go to the pipeline, which 3 letters should be survivable. And then I'm just going to go ahead and execute 3 commands in a pipeline. They're only there to show what happens when, how, and how they do that. So we need to scroll up a little bit. We start with the begin phase for each of the commands. At that point, they have no idea what our input is going to be. There is no value, it's processing nothing right now. Which means that if you have a parameter in your commands that accepts input from the pipeline, you can't use it in the begin block, because it won't work if you receive input from the pipeline, because it doesn't exist yet. What we also noticed here is that we first execute all 3 commands begin block before we go back and start the process phase, where we then execute A through all 3 commands, complete it, then go back and start with the second object. So it's not that PowerShell executes in parallel, really, but all commands in a pipeline are open concurrently. It's only just one active actor, but they are, all the phases happen interchangeably. So when we are finally done, the third letter went through, process is done, the PowerShell pipeline didn't know what to do with the output, so it wrote it on screen. We execute the end phase from the beginning to the end until we're done. That's the basic execution sequence. Well, now I added one slight change now. And that is, in the last execution, we had this message here, process first, second, third. It happens at the beginning of the process block. Now, what I'm doing in this execution is also right when I'm done executing the process block. And will you look at that? The begin phase is unchanged, but in the process phase, I now have command 1, command 2, command 3 starting. Then command 3 is completing, then it goes back to command 2 and it completes that, and then it goes back to command 1 and completes that. Which means the moment one of our commands or scripts is producing output, and it's called in a pipeline, this command is put on hold until the rest of the pipeline is done processing, returns, and then it is allowed to continue. If you have something that is sensitive to timing, if you need to release resources again for that, you need to keep that in mind, otherwise you might have something open for a long time, and we'll be coming back to this in a moment when it comes to error handling, what happens when failure happens. So, I'm a relaxed person, especially after getting that conference talk this morning done, so I like to take a nap. So what happens when our console naps? What if we have a start sleep in one of our process blocks? What happened then? Which is why the second command is going to take it easy now and just going to relax. And there is that particular piece of evidence that we have absolutely no parallelization happening in the PowerShell pipeline. If one of our commands says, I'm going to sleep now, we do not say, hey, great, I've got time to deal with the next item. No, we're waiting. We're all waiting. So, the next part, we currently, and all these demos so far, demo executions, we always dealt with like the way it was meant to be for default, best practices, produce your output and execute it. But what happens when we produce output in the end phase, not in the process phase? Is there some problem with that? For that point, the second command is now going to keep one item. It receives A, it will put it aside. It will receive B, put B aside, return A. And the last item is going to be returned in the end block. So as you can see, we waited on the second command to put A aside, and then we immediately went back to command 1 for the next item. Moved on with A and processed that, and then went on and continued the same thing. And then in the end phase, we produced output in the second command, which caused the third command to go into process. And only then would we return and end the end phase processing. So, time for some bloody murder. Oh, it's like this crime themes there. So the second command is now going to fail with a terminating error, not a non-terminating, with a terminating error in the begin block. And our entire pipeline decided it's good enough. Doing the same thing in the process block works exactly the same way. No matter where in the pipeline we produce a terminating error, the entire pipeline stops. From a design perspective, this has one critically important conclusion. Even if your own command executes perfectly, you can never rely on reaching end because a command downstream could kill the entire pipeline for you. A friend of mine would used to debug a script where his function would write a 500 megabyte database table into the script scope and do the cleanup during end. And then he asked me why I was getting an out of memory exception. Well, there's one last on the error handling side, and that is something that we're going to do in the third command. There's one explicit parameter, the bad input parameter, which is going to immediately fail anything. The validate script behind it is really aggressive. And if our parameter binding, parameter validation fails that for explicitly bound parameters, our pipeline is never even going to start. This system is important to keep in mind. For example, fail as early as you can. Validation in the parent block rather than in the begin block allows you to kill the pipeline before it ever happened. It also means that when you have a regular pipeline and the third last command is supposed to write into a SQL Server database, and we have a really long-running data gatherer at the beginning, and the database is down actually, the third command is able to kill the pipeline before the long-running command can actually start running lengthily in the process block, which is one of the key reasons why we have terminating and non-terminating exceptions. Last but not least, what if our command does not actually implement the pipeline? If we don't have begin process and we don't accept from the pipeline, no problem, right? And that is, on first view, correct. We produce output. We don't have begin process end, but that's okay. We produce output. We go through the process phase of the subsequent command. Oh, great! Until we have this one thing. What when our command fails? The one that does not implement the pipeline, that is the data source, and it fails during validation, which we did not put into the parent block, but into the main script body. Well, the begin phase of the second command still ran. And that's the kind of problem why begin, process, and even in a command that does not accept from the pipeline can make sense. Because if we had a begin phase there and would do the failing in the begin phase, the pipeline would not have continued, at least for that far. If we don't specify begin, process, end, everything is an end. And that's all there is to it.